Kurt Gödel shattered conventional understanding. He's most renowned for demolishing mathematical certainty through his incompleteness theorem, demonstrating that every formal system harbors truthful statements impossible to verify within that very system. While preparing for his United States citizenship examination, he claimed to have uncovered a constitutional pathway through which America's democratic republic might transform into an authoritarian dictatorship. His close companion, Albert Einstein, alongside Oscar Morgenstern, made certain to escort him during his citizenship interview, hoping desperately to prevent him from revealing his discovery, which he almost did regardless. Oh, and regarding Einstein, on one occasion, as a celebratory gift, Gödel presented him with a temporal displacement universe, a mathematical solution to Einstein's field equations demonstrating that even general relativity contained fundamental flaws. Before we dive in, we've got several brief updates. Initially, our ongoing struggle against the algorithm persists. The most effective method to prompt YouTube into sharing our content is through likes and comments. Completing both actions genuinely creates an impact. And for newcomers joining us, subscribe, activate notifications, and share introductions in the comments section. We're welcoming. Moving forward, we're thrilled to unveil our Universe in a Black Hole merchandise. T-shirts and hoodies. If you're convinced we exist, trapped within a black hole, where spatial and temporal dimensions have exchanged positions, and the Big Bang represented merely the opposite side of a gravitational collapse, then this merchandise suits you perfectly. We're additionally continuing to provide our Black Hole Light Curves desktop and gaming surface, displaying how illumination becomes distorted by black hole gravity. Furthermore, our UV-reactive Kerr rotating black hole hoodies, shirts, plus dark energy mugs and apparel remain available. The link's located in the description section. Now, let's proceed to the episode. Stating that Gödel and Einstein shared an extraordinary friendship isn't hyperbole. The elderly Einstein once remarked that his sole motivation for appearing at Princeton involved his afternoon strolls with Gödel. Therefore, when Einstein's 70th birthday celebration drew near, it's unsurprising that Gödel eagerly committed to contributing toward a commemorative volume honoring Einstein's achievements. Initially, Gödel intended composing a philosophical reflection, exploring connections between Einsteinian spacetime and concepts from philosopher Immanuel Kant. True to his nature, Gödel descended into an investigative rabbit hole, and throughout composing this single essay, he developed expertise in general relativity, rivaling anyone worldwide. Then he encountered something profoundly troubling, a contradiction embedded within his dearest friend's theoretical framework. The rabbit hole extended deeper. The submission deadline for his essay arrived and passed, yet Gödel's contribution held such significance that the publication had to wait. When finally completed, the explanation for Gödel's fixation became apparent. He'd discovered a solution to the field equation, general relativity's foundation, proving that Einstein's theory alone couldn't guarantee the orderly chain of causation it was meant to establish. He'd constructed a spacetime metric, essentially a universe, wherein from any coordinate in space and time, circular pathways exist returning you to your original location before your departure. By Gödel's revelation, we'd already identified solutions to Einstein's equation permitting temporal displacement. However, all required something arguably non-existent: negative energy density. Simply prohibit this impossible substance, and the problematic solutions vanish. This prohibition carries the name weak energy condition. Combining the Einstein equation with the weak energy condition appeared to guarantee a deterministic cosmos with unambiguous causation ordering. That remained true until Gödel arrived. He identified a novel approach to temporal travel and causality violation, no impossible components necessary, producing the Gödel universe, wherein time travel transcends mere possibility, it becomes unavoidable. Let's journey into the Gödel universe, first by traveling temporally backward to relativity fundamentals. Within relativity theory, space and time aren't distinctly separated. They're unified aspects of a four-dimensional construct termed spacetime. Depending upon motion and gravitational forces, space and time intermingle, converting into one another. The traditional method for illustrating this employs a spacetime diagram featuring just one spatial dimension. Everything advances upward through time. However, if you're simultaneously traversing space, you progress along a diagonal trajectory. Shallower angles indicate faster velocities, while 45-degree angles represent light speed. This represents absolute protection of spacetime's causal structure absent gravitational effects. Gravity alters circumstances because it walks light's trajectory, consequently tilting our future light cone. For instance, approaching a black hole, light trajectories bend, causing our light cone to curve toward the event horizon, until our complete accessible future resides inside the black hole. Beneath the event horizon, the light cone tilts entirely sideways, meaning the downward direction transforms into your new temporal coordinate. Now, if you could reverse direction and maintain your light cone's alignment this way, you genuinely could journey backward temporally, but within a black hole, reversal becomes impossible. Your future exclusively points downward. Actually, let me correct that statement. Within a rotating black hole, a Kerr black hole, there exists a region deep inside where circular movement becomes timelike. Space rotates so rapidly that a circular trajectory returns you to your starting position at the identical moment you departed. We designate this a closed timelike curve, a CTC. It's timelike in this scenario because you never violated relativity by escaping your forward light cone. These Kerr black hole regions might not genuinely exist, and regardless, it represents fairly impractical time travel, since you're confined behind the event horizon anywhere. We can impose closed timelike curves into accessible cosmic regions by warping spacetime through various exotic methods, wormholes, warp drives, etc., but every case demands some form of negative energy. But then Gödel arrived, naturally. Even before Kerr developed the rotating black hole solution, Gödel recognized that rotational movement provided the key to temporal displacement. The general phenomenon he utilized is termed frame dragging, the twisting of spacetime resulting from a rotating mass, and we've measured this effect. Gravity probe B deployed a gyroscope orbiting Earth. A gyroscope should theoretically maintain constant directional pointing. Actually, Gödel designates the device an inertial compass within his publication. However, the gyroscope aboard Gravity Probe B gradually pivoted from its original orientation as it orbited. Due to both gravitational curvature and the twisted spacetime, the frame dragging produced by Earth's rotation. This angular displacement accompanies a temporal shift. However, regarding Earth, frame dragging constitutes an excessively weak phenomenon for that component to be measured. Yet theoretically, if you orbit Earth correctly, your chronometer decelerates due to angular movement. It's never sufficient to freeze time completely though. Even surrounding a rapidly rotating black hole, no closed timelike curves exist outside the black hole, only deep internally. But Gödel realized this frame-dragging phenomenon could still violate causality if occurring within a space-time where effects can accumulate. The essential task is describing a space-time possessing a fundamental twist everywhere. All coordinates experience frame-dragging, not exclusively around a solitary spinning object. We state it possesses global vorticity. All space-time coordinates rotate relative to neighbors, not like every location spinning individually, but rather resembling a vortex of world lines throughout an infinite four-dimensional space-time, lacking a center. Additional requirements exist. A negative curvature hyperbolic geometry is necessary to permit centerless rotation, plus a balance of uniform positive matter and negative dark energy to maintain the universe's static dimensions. But calibrated correctly, Gödel demonstrated that such a universe can overflow with closed timelike curves. Let's observe what it resembles. This saddle configuration represents a two-dimensional hyperbolic space. We're preserving the actual z direction for time, enabling us to stack these planes representing a four-dimensional universe. Magnifying inward, it appears flat locally. However, the negative curvature persists. You don't perceive anything unusual traversing this space, even though the underlying twisting exists. You notice this when time advances forward, and neighboring particles follow twisted trajectories. From any coordinate in this space, as you travel outwards, your light cone tilts relative to your starting point's reference frame. And beyond a particular distance, the Gödel horizon, it is tilted sufficiently to permit travel into historical time, or minimally, to recover some temporal duration you invested traveling. But with carefully designed routing, traveling in a circuit, you can steer your future light cone to ultimately encompass your starting coordinate. Another conceptual approach is that by mixing time with the angular coordinate, your circular motion substitutes for, and even reverses temporal progression. Correct, Gödel invented the time turner, rotate sufficiently, and you journey backward temporally. But with limitations. You must travel outward beyond the Gödel horizon from your starting coordinate, meaning you cannot simply rotate in place and enter the past. The time-traveling capabilities of the Gödel universe are entertaining, however, they aren't the genuine objective. The genuine objective is that this solution to Einstein's equation represents a counterexample to the notion that foundational general relativity, the Einstein equation, combined with the weak energy condition, suffices to ensure sensible universes. Previously, any valid GR spacetime could be divided into layers of sequential present moments, where the precise configuration of everything, the particles, the fields, within each layer, can generate the subsequent layer. This perfect global determinism isn't valid in Gödel's universe, and the past and future become entangled and not clearly distinguishable. Gödel proved that general relativity doesn't guarantee spacetimes possessing a rigid causation ordering. At minimum, in certain cases, like Gödel's universe, we cannot determine whether A caused B or B caused A. What Gödel genuinely revealed was that prohibiting negative energy wasn't adequate to ensure sensible universes. Others emerged and proposed additional conditions. Global hyperbolicity was suggested as an explicit requirement, which bears no relation to hyperbolic geometries. It essentially declares that for any physically reasonable solution to general relativity, any constant time slice must comprehensively determine the subsequent constant time slice. And that must remain true, regardless of how you perform that temporal slicing. Then arrived Stephen Hawking's chronology protection conjecture, which proposes that any spacetime permitting closed timelike curves is unstable. Feedback from time-traveling vacuum energy will trigger the ultimate reverberation and collapse the universe. So, that's genuinely what Gödel presented his companion Einstein for his birthday celebration, the motivation for future generations of physicists to continue working on Einstein's greatest theoretical framework. Gödel didn't demolish Gödel, however. He revealed to the rest of us where some of the few remaining fractures exist. Fractures which may, eventually, guide new Einsteins and new Gödels toward deeper theoretical frameworks.